Let's give a round of applause. So now we'll move on to our next presenter. That is, I'm sorry, I'm going to butcher this name, but Mr. Gabriel Vukure. Mr. Gabriel, if you're ready, please proceed with the presentation.
Good evening, everyone. Thank you for giving me this time to present. My name is Gabriel Vukure. My topic is investigation on the impact of hemp fiber reinforcement on mechanical strengths and the biodegradability of PLA in additive manufacturing for circular economy application. My presentation has the list of introduction, problem statement, as you see, up to budget. The background of study: additive manufacturing or 3D printing is advancing modern production system. So here we have a polymer called the PLA, polylactic acid, originated from, it is a bio-based polymer, either from corn or sugarcane. It is a widely used because of its biodegradability and renewable origin. But as you know, it is brittle and it has low strength. Natural fibers, we have many, but according to my topic, we are choosing hemp. It has been studied as a fiber which can improve the mechanical properties while maintaining sustainability. PLA hemp's composite supports circular economy. It is eco-friendly. And the good thing, hemps and PLA, they are all biodegradable materials. So we are going to hear how they will contribute to circular economy. Challenges still remain in fiber dispersion, interfacial bonding, and print quality. So the study investigates the effect or the influence of hemp on the reinforcement of mechanical performance and biodegradability. So problem statement: as we said, PLA is used in additive manufacturing because of different good characteristics we will see, but it is brittle. And according to my application area, so and the natural fibers such as hemps, they improve mechanical properties, but their effect on biodegradability and performance is not fully understood. Fibers and polymers, there are a lot of investigation and studies are being done on polymers and fibers, but they are not fully understood as metals. Fiber content, treatment, processing conditions leads to consistent composite. Even if we are talking about degradation, it is influenced by environmental factors, temperature, moisture, microactivity, and making prediction difficult. We will see in the next slide that if we want to have biodegradability, but there is no full study or understood, because temperature, we'll see how it can affect it, moisture and microbial activity. There is a need for systematic investigation of hemp fiber enforcement to optimize both mechanical performance and my objective is just to investigate on the impact of the enforced fiber hemp's enforced PLA in additive manufacturing for circular economy. Specific objective: 1. To blend PLA hemp material to obtain optimal composite material for 3D printing of structure materials for structure applications. There, for specific objective, save time. That specific objective number 1, we will first prepare hemp. We have to make sure before we blend, there is a preparation of hemp needed by reducing size, because my interest is to work on size of less than 150 micrometer. So we reduce the size so that we can have fiber dispersion. Also, we have treatment. Fiber, we have a lot of treatment, chemical treatment, but me I will use alkali treatment, sodium hydroxide, so that I can have surface modification for proper bonding. Then after treatment, we shall blend them, we shall mix them. Then second objective, to fabricate composite filament and 3D printing standardized. So after first objective, we will convert the composite into filament. For that filament will be needed for FDM, but under controlled processing parameters. As you know, working in fused deposition modeling, to have optimal result, we need parameters in temperature, in nozzles. We see them to evaluate mechanical properties. Our purpose is plastic, and STM D638 is common for plastic. We shall evaluate our mechanical properties for tensile based on that standard. To assess the biodegradability of composite under controlled composting and soil barrier conditions using. Here we have two options. Number 1, industrial composting, where we shall subject our sample in industrial composting at certain temperature and also for a specific period of time. For example, for industrial composting, if we take our sample and we give it temperature of 60, also for moisture content between 40 to 60%, we give it specific time, we can achieve our specific objective number 4. Justification: limited understanding of combined effect on strength and biodegradability. A lot of researchers are talking about mechanical performance and biodegradability alone, but here there is a limited understanding of the combined effect on strength and biodegradability with EDM. Also, study aims to optimize fiber content, treatment, and processing conditions. This is the key point. The range of fiber content is between 0 and 30%. We will use Taguchi method for design of experiment to see how they will give us nice optimization. Why PLA? PLA, it is a bio-based polymer. It is not a petroleum-based as the other polymers. So it is derived from corn or sugar cane, and the PLA is used in 3D printing. It has high mechanical strength and stiffness, but it is brittle. Low heat resistance. Environmental concern. Biodegradable under industrial composting condition is possible. PLA is used for different applications, either automotive, construction, packaging, medical, even aerospace, but suitable for food and medical use for this purpose. This table is trying to compare different polymers, but my interest is part 1. PLA is sourced from corn or starch. Biodegradable, yes, it is possible, but other polymers, it is not possible. It can allow ease of processing. This is showing how PLA is a promising polymer. Also, hemp fiber is a fiber. To try to summarize this, it is a fiber which has cellulose, and those cellulose can help bonding or mixture. So that to high cellulose content for strong reinforcement. This cellulose can help in reinforcing or bonding. We will see it in methodology. Also, for environmental concern, it has the ability to capture carbon dioxide so that it can reduce it in the atmosphere. For our purpose, it has excellent ratio for efficient stress transfer. To have fiber dispersion, we need a good stress transfer. It provides the best balance of strength, lightweight performance, thermostability, and etc. The reason why it is reinforced with PLA, there are many reasons, but it can enhance impact, wear, and vibration resistance. It improves tensile strength. PLA has 50 to 60 megapascal, but when you combine with Hemp's, some studies they shows that it will improve that one. Some application of this brand in automotive, the study is showing that when you take biocomposite, the more you have lightweight material, the more fuel consumption is reduced. So by introducing this sustainable product, it can reduce, which is the most problem in this world. For packaging, as you see, they are good in packaging. Even in a problem statement, most of waste, they are being put in a damping area. But when we are able to design something which can decompose after 90 days, or this can contribute to circular economy. Also in construction, this is some literature review. PLA is widely used in 3D printing because of its easy processing. So reinforcement with hemp, it will improve tensile strength. This is also literature review. Alkali treatment, it will give better fiber matrix bonding, which is also the good point. Also natural fiber accelerate PLA biodegradation, since all of them are biodegradable. So they are hydrophilic. They are able to absorb water and to allow microorganisms to penetrate so that it can be biodegradable. So research gap, existing studies on hemp fiber reinforced PLA mainly focuses on mechanical performance only or biodegradability alone. But here we need to see the effect of combining them so that you can have a balanced result. Most studies used short fibers and conventional manufacturing methods with limited optimization. Even if a lot of studies are being done in natural fibers, there is still poor interfacial bonding. That's why the studies is ongoing. That's why we keep on researching on to make sure this poor bonding can be resolved. Our methodology, we start with research design, then we come to material selection, we go to treatment, composite preparation, filament fabrication, characterization and testing, biodegradability testing, data analysis, interpretation and conclusion. So some of the materials, we will have pellet. This pellet we will supply. We will like buy them. Can either use online platform or we order them from China. Our base material is pellet. Then we have hemp fibers. Also, we import them. They are in France. Then we will have compatibilizers, especially Hemp. For equipment, we will have big number of equipment. These fibers are supposed to be grinded, crushed, and bone milled so that we can have size of less than 150 micrometer. We will have digital weighing balance, drying oven, alkali treatment, screw extruder, which is also more important in fiber dispersion. We will have 3D printer, UTM for tensile test. We will have SEM, electronic microscope. About treatment, the purpose of treatment is to modify the surface so that it can be rough, and when something is rough, it is very easy to bond. We use sodium hydroxide 30 minutes to 3 hours, concentration of 6% at room temperature. So after alkali treatment, we shall do washing so that we can remove chemical substances and dirties. Then we dry, wash to remove chemical substances, then we dry. Composite preparation, I will have 3 samples in Taguchi method. Blend PLA with hemp fiber 10, 20 to 30%. Extrusion using extruder parameters like temperature between 210, there I forgot, is 200 to 210. For Taguchi method or design of experiment, we will take 1 sample of 10% of hemp to 90. We will first take 10%. Factor number 1, 10%, temperature 200, screw speed around 30. Then for the same level, we take 10% mixed with 2 to 10. Then we change screw speed. Then we take 10 to 20. Also we change speed of screw, so that at the end we do the same to 20 and to 30%. At the end we will see which sample is giving us the balance of improving strength and biodegradability. For filament fabrication, we will produce a filament which has 1.75 millimeter. Print. For my test, I will design a bone, like a dog bone, which will facilitate tensile strength. A dog bone, I will design it using CAD. Then I print it using that filament. Also for characterization and testing. For biodegradability testing, after forcing our sample to test, after the period of testing, you have to test weight loss, appearance, and mechanical strength to see whether our product has decomposed or not. For soil barrier method, we shall put our sample in soil for 6 to 90 days. For industrial composting, we shall expose it to temperature of 50 to 60 and humidity of 40 to 60. Under controlled parameters so that we can see if the weight will be reduced or other parameters. Also, we shall do that analysis. Our research work plan, it is for 12 months, and I believe by December everything indicated here will be done. For baguette, it is a general baguette which will cost 200,000 Kenyan shillings. These are some references, and this is the end of my presentation. Thank you for listening to me.
Give him a hand. Thank you so much, Gabriel, for that presentation. Interesting and insightful. Thank you, Professor Bashir. Move on to our next panelist. This is Professor Gabriel.
Thank you, Chair. Thank you, Gabriel, for the presentation. It's quite interesting. It's very interesting, and I can can assure you the way forward is clear.